Okay. That's okay, so let's see. We have the very first problem. What was that? Oh. Oh, you turned it off. I didn't. It's looking for it. Did I actually turn it off? I didn't touch anything. Right. Walking front of it, it's like all. Yeah, when I go outside, it'll fire it in. Yeah. Okay. Whoa. Okay, so we're ready. So the very first question, you guys are supposed to fill out this table. Now, the thing I want to tell you that if you guys practice. So when you have this table, you need to make sure it's tab. That's how you get to the last ones. You have to hit tab. Okay. So let's see. You see the example. The very first one says carbon 14. So then, what is the atomic number for carbon? 6. Okay. What is the atomic mass for carbon 14? 14. So 14 is that new mass. So that's what you group on. Okay. Yes, because it's nice. No, it is enough. Yes. But if it's not given to you, that it's not an isotope, then you're if it's not an isotope of carbon, I mean an isotope of that element. Okay, so then the mass number is going to be 14. Different in the atomic number. So if we have an element that is on the periodic table, you're going to use the atomic number that's there on the periodic table. Right? And that's if it is not an isotope. So I'm going to use an isotope and just be the average of an element on the periodic table. How do I know it's an isotope? Well, the weight can be different. Right? And it will show either up in the corner like this, or we will say dash that weight. Okay. So the mass number is a whole number. It always has to be a whole number. It's going to be that the mass of that isotope. Number of protons per carbon. 2. Electrons. and neutrons. 8. Okay. Guys, how do we calculate the number of neutrons? What's that? The mass minus the neutron. Okay. So, barium 2 plus 140. Okay. So barium 2 plus 140. So what would be its atomic mass? What was that? What would be the number of protons? 6. What would be the number of neutrons? 84. Okay. So what would be this element? Now, figure out. If we work back, what is this atomic? 17. How did you figure that out? Protons. What is the atomic mass? So then what is this isotope? Or what? 1%. What was that? Yeah. Because we can't have this program. Was that? But Lorraine, what would be the number of neutrons? Okay, for the last one, what is the atomic number? What is the number of protons? You can answer. Okay. Number 2. Cracking a glow stick is a physical or a chemical reaction. It's a chemical. It is a chemical reaction. Boiling water. That's water. Sticking down, right? So let's go. Mentos. A gas burning in a fireplace. That's chemical. Visible. Put it back. Right. That's right. Chemical. That's how. Okay. Yellow rust. It's chemical because it's electrons. Chemical. Because you're oxidizing iron.
Yeah, you were ready.
That's beyond me. Speak by the library. You gotta find some library. Okay, so determine the number of significant figures for the following. 3. B.
3, 5.
3. Is the correct answer? C. 3.
But
What?
like when I'm asleep, that's how I was like,
That's right. Yeah. So 21.00, 12.005, 7.0000004, and 0.012.0, and then 100. Okay, this part is subtracting, this is all addition. Okay, so we do. So together we line them up. Where does significant is for the first number? First number. Where does significant is on the one? Sure.
Where the balance is right on the, where there is.
After the zero? After the zeros. So the decimal point there, so we're saying that's important, right? So after the zeros. What about the second one? After the 5. What about the third one? After the 4. Running out of colors now. What about they got purple. What about the fifth one? I mean the fourth one? After the 0? And then what about the last one? After the 0?
Oh, after the 1.
After the 1. That's right. Okay, so let's go ahead and add this up.
Wait, why is it not?
Because there's no decimal point there, right? Since there's no decimal point, these guys, these zeros are not considered significant. Only that non-zero number.
We go down, right? So, okay, where is my?
Yep. So this is the one that's going to be our, where we're going to make our decision whether we're around there. What was that? That's right. Okay, so let's go ahead and add it up. It is 4, 0, 0, 5, 0, 0. 1. Carry the 1, so that's 4. 4, and then 0, 0, 2, 1. What was that? Okay. So we use this as a 4. Is that greater than 5? No. So the answer would be 2, 0. We have this 0 is going to be significant, so I'm going to put a bar over it. And then I'm going to put 0, 0, right? Or I write it like that. Or I would go 1.20 times 10 to the 1, 2, 3, 4. This one is easier to see. I have 3 sig figs. So the answer would be 3 sig figs. John. Does that make sense? Your whole system?
Your whole system is the right answer.
What was that? So, no, it's right. Is that the one? Okay, it's right here. So then you can have over 1, 2, 3, 4. Because you're always going to put a single digit and then numbers significant figures out. Little 3 sig figs. Questions? Okay. The next one. Car is leaking gas at a rate of 0.0250 gallons per minute. If the car has a 12-gallon tank and it's full, how many hours will it be before your car is leaking?
Eight hours?
8 hours. It is 8 hours. How did you get that?
By,
Does anyone see Virginia? Back over there. Okay. So you said we have 12 gallons. And you said something about converting.
yeah.
Okay, so then you said we used our 0.0025. Oops, I got too many zeros there.
That equals 1 minute.
Or,
Yeah.
okay, and 1 minute on top. And then so 60 minutes and 1 hour. Okay, so then my answer should have how many sig figs? 4.
Do you always go off your significant number? You always go off your given number?
That's if you're doing only like a conversion, right? And then you have like this here is acting as a conversion because that 1 is kind of like a negative number, right? And this one is an exact number, right? This is an exact number. That's how I say 1.000000. Right? And then this guy does technically good influence, but it's used as a conversion, so you're not going to. That makes sense. Okay. Then the second part. I was to see if you were driving from Firebaugh to Salinas at 101 miles to see your new boo or maid, you met in chemistry class at a speed of 75.0 miles per hour. See, which you make it before you ran out of gas, assuming your car gets 32 miles per gallon. You started with the full tank, and the car is still leaking gasoline at a rate of 0.025 gallons per minute. How many gallons of gas are left or short? Please show your work to support your answer for fourth grade.
You have to convert. You have to get how efficient the part is, right? Correct.
So what am I gonna get?
So get 100%
Convert miles to hours. Okay, so how would I convert miles to hours? I have 101 miles. Hours. What do we need to convert to hours?
So
75 miles on the bottom and 1 hour on top.
$1.34. The 1.35. That is.
Okay, so then we have hours. So what are we going to do with that?
5 miles. Oh,
So is that
1.35 miles.
Divide this by the miles.
Hold on.
That would just give us a back.
You gotta use.
Oh, times it by the minute per gallon.
Okay, so I times it by the minute per gallon. So I have 1.35 hours. So, but I have hours. How do I change that to it?
1
To
hour.
minutes. So 1 hour equals 60 minutes.
Oh, and 1 minute equals 22.
I was going with what she suggested first. So 0.0250 gallons per minute. So this would give me gallons, right? The gallons that we lost. Is that correct? Gallons lost to the leak, right?
The gallons that we lost per minute, right?
No, the gallons that we lost to the leak. Remember the leak? Okay, what did you guys get?
No.
2.025. How many same things should I have?
No, 2.02.
No, remember, you, that does sound bad. Oh, it is?
That's right.
Oh, okay.
Okay, that's right. That's due to the leak. Okay. That was the distance that it takes us to Salinas, right? Yeah. So it takes us an hour, and so this is how much time, this is how much gas we lose as we go driving. Okay. So then, what is the next part?
Cars. Oh, so this is the plug in number. You will have 2.02 gallons there. You get right?
What else? What else? Okay, so we have 12 gallons. We have a total of 12 gallons. Huh? Yeah, it does have a calculator, but you're able to use a calculator. So we have 12 gallons. So this is what we're starting with, right? And so far, we've got the lead. That's 2.02 for the lead. Okay, what else?
The 1 point.
Okay, so well, we know the total miles, so this is all gallons, right? So how many gallons are we going to use? How do I figure that out?
So with 12 gallons, you need 2.2 gallons to get to an hour and 35 minutes. Right?
What was that?
Gallons over miles, right?
We have gallons over miles, okay? So if we have to start again with our 101, miles. And then you said gallons over miles, what is it, 32 gallons? For 1 mile. Miles canceled out. Is it 32 miles per? Okay, I'm backwards.
Yeah.
I'm like, that is not right. 32 miles per 1 gallon. Miles cancel out. I'm like, yeah, you would definitely not make it. That is horrible. What's that? 3.16.
Well,
16 gallons. Okay, so then we subtract 3.16 gallons because this is how much we're using to get to Salinas to drive, right? Because your gas uses gas, right? I mean, your car uses gas, or gas uses gas.
That's per month, right?
Yes.
3.6 gallons per month.
No, this is 3.16 gallons. Period, right? That's how much you're using to get to Salinas. Salinas is 101 miles. This is how good your efficiency is, right? Your car is a gas guzzler, right? Yes. So for every 32 miles, actually, it's not that bad. It's actually pretty good. Gas guzzler would be like 14. You know, like some of the trucks that you guys have.
So that would be
Okay. So we have what's coming from the lead, what's coming from how much it takes us to get there. You know. Okay, so we add that together. What are we going to get? .82 gallons. And it's a positive number. So do we make it?
we made it.
That's right. We can probably make it back, right?
No, we're gonna find out.
No, actually, you would make that. Okay. Unless you let your car sit too long. If you spend a couple of hours there or a day there, yeah, you're screwed, right? Yes, that's how much is left over, right? If it was a negative number, what would that be? We're short, yes. That's right. Okay, questions? Concerns? Getting that not organized, right? And all of this stuff has been thrown at you. It's like, hey, here's one thing, here's another thing, here's another thing. You have to organize. That's exactly what I want to do. Because that's what life is about. It's about trying to figure out those problems. You got to organize it. Yeah. Okay, next part. It says, if your car overheated on the way there to a temperature of 325 degrees Fahrenheit, what would be the temperature in Celsius and Kelvin? Everybody got this part? I got the next one. That's all right. It's gonna be your price of gas. Price of gas. Okay, I'm good. What am I doing?
Converting Fahrenheit to Celsius first.
Okay, so how do I do that?
5 over
5/9.
9. Parentheses.
When you're
Fahrenheit.
okay. And then
Minus.
okay, so then it's so this is same thing as saying 325 minus 32 over 1.8. You guys should be some parentheses, otherwise.
1. $162.77. And how will we get the signal?
Okay, so these here are considered to be exact numbers. So you don't have to worry about those, so you just need to worry about what's on the inside. So how would I do that? Where does it fit in? Yes. On the bottom, so we 1.8. If you divide 9 by 5. Sorry. There's just things to say about it. So how many things? Oh. So these numbers, since it's the conversion right here, this is considered to be exact numbers. Right? So really all you're looking at is what's in here. So then where does significance end? We have 325 minus 32. Where does significant end? Okay, so then you should only have say this 2. I should have 3, right? So 3. 2. 293, and then we divide that by 1.8, so then our answer should be 163, right? Are you crying? It's okay. Okay, 163. Okay, so then how do I find Kelvin? Okay.
E plus Celsius plus 8.
Sorry, I need Irish. Yep. 163 minus 273.15. That's an equal. What's that? 420. Oh, no. No, it's Celsius, it's plus. It's plus.
Oh, wait, yeah. No, never.
You're the one that told me, like,
I was like, yeah, I have it on here. I have it on. That was like a question for arguing.
Okay, so we do the math.
Oh, wait, you forgot the. Wait.
Or what?
273.17 on my end.
It's 0.15.
Really?
Yeah.
Wow.
Wow. So 163 plus 273.15. Except for what? 36. So why is it 3 sig figs?
It's
What's that? Okay.
I probably did it wrong.
163.
I found my area.
Okay, piece of cake. 50 points, right? Okay, let's balance this chemical equation. What was that? Whoa! Okay. Okay, so when you guys do this, if you guys leave it blank, meaning that it's understood to be a 1, you guys can put a 1 there because Canvas, if I left it blank, it would accept anything. So I have to have a 1 there.
Oh,
Yeah. So if it's, you know how we normally just leave it blank and it's understood to be a 1, right? So in this case, you want to put a 1 for this example. Yeah, they're not, they have a hard time with certain things in chemistry. Did I hear something? I heard the answer. Okay. Okay, where am I going to start?
so
right now,
Okay. I got Ellen, CHO. Hey, we're gonna switch. CHO. What are you gonna do next? He's gonna lead the discussion. I'll be right back. Right.
right now, 12.
right now, 12.
Yeah, 12.
Okay, outside.
Okay. How we balance carbon first. So how many carbon are we on the carbon section? That changes your oxygens on the carbon section.
Just.
Because they said.
What? Oh, I hear you.
Huh?
That changes your hydrogen. Still not balanced, yeah, you know.
The 12.
That changes their oxygen. Yeah, so what's that? That balance there. There, but someone else. Oh. You got two oxygens, your whole time. Four. That reaches the most.
Those flashcards? Oh, that's good. I like flashcards.
They're golden tickets.
So what? Okay. I want to. Oh, got it.
For the bear. So in this case. Like the person who didn't.
That's right. We
We
put
would
a
put
one.
a, we would put a one.
Yeah. So we would enter the one.
Right. And then on that side, the 12,
Well,
and then 12 again.
well. So balance the following chemical equation. Okay, what am I going to do? Now that's Cl. That's the I. Yes, that's Cl. Capital C, lowercase l. Because the I is going to be like this.
I don't know.
Okay. You said this amount. N H Cl. What was that?
One.
So N is one, and then two on this side. Okay.
Three on the other side.
One
Yeah.
That's on the other side.
Or mix up that up.
Yes, actually, the arrow separates the products from the reactant.
Yeah, what?
Okay. Okay.
Four.
4, and then on the other side,
Two.
and then
One. And then two. 4.
okay. What we're gonna do? First, in front of the end. Okay, so then that gives us 2 nitrogens, 8 hydrogens, 2 chlorines, and 8 oxygens. Okay. Then
Put 4. For the,
4 in front of the chlorine.
yeah.
No.
Oh, yeah.
So chlorine is good.
Put a 4.
Put a 4. Okay, so we put a 4 in front of the 8. So that would be 8. And then how many oxygens do I have now? Plus, I have 6. Okay.
Oh, and then you should multiply. The O, that would give you 4. 4 plus 4. 8.
Yes. Okay.
Let's make a part of that.
Okay. So at first we had 2 that are here, right? And then we have 4 that are here. So 2 plus 4 is what? It's 6. It's not 8, right? And then he said if I put a 2 in front of here, that would give me 4 plus 4. 4 plus 4 is 8. 8. 8.
Last part, each door before.
So always remember, this here is the coefficient, so it's distributed, right? So you multiply by this, and you multiply by that, right? So what's ever behind there, both of those will be. Or another way of looking at it is that you have 4 waters. H2O, 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 H2O. So how many oxygens do you have? You have 4. Okay. And when in doubt, write it all out, you know. Okay, questions? Concerns? Anybody want to give $1 million? It's on budget right now, it's supposed to be going up, you know. Next week it goes up to $2 billion. Okay, so which of the following statement is false? Which of the following statements is false? So I'll read them out and then you tell me if it's false. Okay, first one, it says the potential energy of an object depends on its position in a field where forces of attraction and / repulsion are present. Okay, so that's all right. So we believe that's true. Okay. Any moving object has kinetic energy. So that's true. The minimization of energy is one of the driving forces that causes chemical reactions to occur. So let's put a question mark by that. Question mark. Kinetic energy is always greater than potential energy for an object. If it's just sitting here, does it have any kinetic energy? Then that means the potential energy is
Greater.
that's true. No, it just depends on the object, right? So if the object is totally at rest, right? So my eraser here, is it moving? So then how much kinetic energy does it have? None. Is 0 greater than something? Because its potential energy is based upon its height, right? So if the potential energy is based upon its height, then the potential energy here is greater than kinetic energy. And we know that energy is conserved. So as soon as I knock it off the table, then my potential energy is changing, and we're losing potential energy, and we're gaining kinetic energy, right? But that's when I knock it off the table. But right now, it's at rest. It potential, you mean kinetic, would be greater when it's moving. Yeah. Potential is greater, yes. When it's not moving, when it's at rest, the potential energy is greater, right? But the potential energy can still be greater if you have it in a position. Let's say, for instance, we're on a hill, right? And we're trying to push this car up the hill. So initially, it's going to be low potential energy. The more that we push it up, it's going to be more potential energy. The more we push it up, it's going to be more potential energy. So it's going to be increasing as we push it up.
Is that because if it falls down, it'll have more,
Yeah, because gravity is acting on it, right? So it's going to be height and gravity that's going to determine how fast it's going to be able to go, right? So like if I knock this down, then it's gravity that's going to be determining that height and that gravity is going to determine how much kinetic energy. Okay, but initially it starts off slow and it speeds up. It's going to be at its fastest point when it hits the ground. It's also going to be the most energy. That's right. Because depends, right? So we know that that one is false. So the reason why chemical reactions occur is because you don't want to use energy. Minimization of energy basically means I want to be lazy. I want to sit on the couch and watch TV, right? If somebody would pay me to sit on the couch and watch TV, guess what I would do? Sit on the couch and watch TV, right? So it's this one. It's the false. We'll read the last one just in case, because sometimes what happens is that we get things all scrambled. So most of what we call mechanical energy is kinetic energy. That's mechanical, meaning motion. Okay. Okay. This is the one that everybody loves. It says, which of the following changes is/are endothermic for the underlying object? Okay, so baking a potato. So is that going to be endothermic for that potato? If it's being baked?
yeah.
Heat is going inside, okay? A person being burned by a pan. Are you going to be endothermic?
I honestly, because
That's right. That would be endothermic. Okay, so those two are endothermic, 1 and 2. Okay, so what about 3? A wood log burning.
It releases that.
Okay, so is that endothermic?
That's excellent.
That's exothermic. Okay. Number 4, a lit light bulb shining.
It releases the shine.
So it's releasing. Okay. Number 5, a person digesting food.
Like pooping.
That's part of the digestion part of it, but that's like the last part of it. I love this class. So you guys think it's just 1 and 2? How many of you guys think it's just 1 and 2?
I think it is, but like, I don't know why. I don't see why 5 wouldn't.
Okay, that concept of digestion, right? So just think about when we talk about sugar, right? So we eat sugar, what are we eating it for? To release what?
Energy.
To release energy, right? So we digest food to do what? Release energy, so that we can use it, right? Okay, so would that be endothermic for releasing energy? No, it would be exothermic, right? So the correct answer is 1 and 2. Good job. Okay. Oh, this is a really identify the reactions and the products in the equations.
Oh, that's pretty.
Reactants. H2SO4 and HCl. First one?
No.
Not the first one? Okay. Reactants, BaCl and BaSO4? No. Okay. The third one, BaSO4 and HCl?
No.
No. The fourth one, H2SO4 and BaCl? Okay. What is it missing? You don't have to worry about the coefficient in this case, right? They just want to know which elements are. Yeah, and this is, again, this is a part of the chemical formula that just tells us how many of that we have. That's what the coefficient is. So the correct answer was that, yes, you don't worry about it when they're asking you what are the products and reactants, because you're just talking about okay. So it's the formula. Okay, so the correct answer is number 4. That's interesting. I'm glad you brought that up. I'm glad you asked that question. That reminds me that next time I teach, I will make an emphasis on that. That's probably why I've seen that.
I would still think that was the best answer.
Yeah. Okay. Which of the following is false? IF is a formula of a compound. Is that false? See what an I looks like now? You see what an I looks like now? Oh, yeah. It's not if. It's IF is a formula of a compound. Is that a compound? Is IF a compound? It's not. Okay, take me back. I'm getting over here. I know it's been like, a couple of weeks. So a compound, what is the definition of a compound, David? Okay, wait, I'm asking you a question still, that doesn't mean you get out of the question. So what is a compound? Okay, say elements. They're coming together, they're bonding together, okay? So two different or two the same? Or the same? You said two different that are coming together. Okay, so what is a molecule? A molecule can be two of the same. Can it be two different? Yeah. Yeah, that's right. Okay, so that's right. That's right. Okay, so the second question. So we know that the first one is true, right? Okay. The second one, it says an elemental symbol is a capital letter, sometimes followed by a small letter. Sometimes followed by a small letter. So in other words, so an example is CL, right? Okay. So that's true. Okay, the third one is if there is only one atom of an element in the formula unit, it is indicated by the subscript 1. This is what it's saying. If there's only one element, like H2O1, do we do that? Do we ever write water that way? No. Okay. So would you say that that's probably the one that's false? Okay, so put the confirm. Okay, H2 is a formula of an element. Yeah. Because we know which of the diatomic elements? Hydrogen and carbon, nitrogen, oxygen, fluorine. No, not helium. Have no fear of ice cold fear. We had hydrogen was our have. No would be nitrogen. Fear would be fluorine. Of would be oxygen. Cold. Ice would be. Cold would be chlorine. Fear would be bromine. Or if you remember, the 7 plus 1, right? It's a little 7 in the corner. Graph table. 7 plus 1. 7 plus 1. Okay. And the last one says the properties of a compound are always different from the properties of the elements which they are formed. What do you guys think? What's that? That's true. That is true. Yeah. Because think about H2O, right? Water. And water and oxygen, are they the same? What's that? Yeah. Yeah, that should always, if they say something is always, it should be always thing. I don't know about that. Right. So, but in this case, it's true, right?
So what makes it a molecule?
A compound
A molecule is not always a compound. Right?
All because a compound is so different.
That's right. That's right. So, for instance, here, nitrogen and oxygen. These guys are molecules. Are they compounds? No. But water, that's a compound, right? It is a molecule, yeah. Right? Because a molecule is a very general definition. It's two or more, right? All you need is two or more. Just two or more. That's it. Okay? So, if it's, doesn't this obey that two or more rule? Does this obey the two or more rule?
Yes.
Does this obey the two or more rule? Is it two or more?
Oh, yeah.
It is. Now, if I said two different atoms or more, then this one obeys that. Okay? It's a compound and it can be a molecule. For this one, it's only be molecules. Virginia, can you hear us? Let's see. It says, like chemists use models of atoms and molecules. I'm not talking about the ones that walk the runway.
I believe.
Okay? Sure. Okay, so which of the following? So which of the following particular level picture might be associated with the name silver? Silver.
Well, silver.
Which one do you think it is? The second one? Why do you guys think it's the same? That's right. It is the same one, and they're all exactly the same. If it's silver, you're going to have just exactly the same element, right? So they're all going to look the same. We're having a lot of trouble with that camera. Okay, where this one, we have, something here, something there, we have something that's bigger that's there. So this is definitely not an element, right? And then this one has a big one, and then you get the small ones that are connected together. Right, so that's that.
And what is that?
This here?
Yeah.
That's another element. So you have two different elements that are lined together. Because remember, this here is just, these are called space.
So that's complex.
Well, that, yeah, so this would be a compound.
And all the elements are like that? Like
Yeah, so if you look at this,
this.
each circle represents an element, right? This represents a single element. These are all exactly the same, right? And then they're compacted, so they're nicely together, so that would be a solid. We know that at room temperature, silver is going to be a solid, right? So you guys heard silver. Somebody has a silver ring. Okay, he has a silver necklace, right?
So, you know, it's a solid, it's not a gas, right? And then if it was gas, it would be everywhere, right? Spread out. So we know that this guy is a gas, but we also know that these two are exactly the same, these two are exactly the same. So this is a mixture, right? This is a mixture of gases, two different gases, two compounds of gases. And then this last one, this here is also another example of gases, but these are gas elements. And then these guys, they're far apart, so they're probably a gas compound.
So, I have a question about silver. Silver is just like the word, like, is that what you would see, like, defined? Or is silver just like saying, like,
No, silver is an element on your periodic table.
oh, okay.
That's like gold is an element, right?
Yeah, I just wanted to make sure, like, oh, that thing is silver, although it's not silver, but like, you know what I mean?
I see what you're saying. You're saying they're using it as a characteristic.
Yeah.
Yes, that's the thing about silver. Oh, it's, what color is it? It's silver, right? And you're thinking, well, it looks like silver, but it's not silver, right? Okay. Most methods for separating mixtures into components depend on which of the following. First one, differing physical properties among the compounds. B, differing chemical properties among the compounds. C, differing electromagnetic properties among the compounds. D, differing normalized properties among the components. I keep saying compounds, components. E, differing spectrum, I can say that, spectroscopic properties among components.
Different.
Well, my language gives it away. Yeah, no, guys. I wear my emotions on my sleeve.
It's not physical. It's physical, but
I can't be physical. You have two compounds. One boils at 25 degrees and the other one boils at 100 degrees. Can you separate it? Yeah. Is that a physical property or is that a chemical property? That's a physical property. We have two compounds. One of them is a solid, one of them is a liquid. Can I separate it? So think about things in real life. Think about the coffee grinder. Remember we talked about the coffee grinder? We talked about alcohol. Try to think about picture, right? That'll help you with some of these problems.
but at the same time, I don't know what's the thing. You couldn't even see the word.
Yeah. The spectroscopy, right? So that means the rainbow. Remember when we looked at the rainbow?
Oh, yeah.
Okay. So you're like, no, we're not separating things by rainbow, right? That's bullshit, right? It's like, hey, let's see if you guys are accept bullshit, and that's bullshit, right?
Different.
So again, that's like radiation. Are you separating things by radiation? Yeah, do we have battery towers around? They're hot. You know? Okay, so and then chemical properties, right? Are you like if you're heating it up, if you're breaking bonds, right? But we're not doing that. We can separate waste. Right? Yeah. But they said, yes, they said mixture. So we, since they're different properties, it's like separating iron from particles, right? We use magnets. Number 14, which of the following does not describe a mixture? Which of the following does not describe a mixture? Two or more pure properties. A distinct set of physical and chemical properties. Components that can be separated by physical change. Boiling temperatures of a solution will increase with time. All of the above describe a mixture. What was that? Okay, so which of the following does not describe a mixture? Two or more pure substances. And make sure you two or more pure substances. Add together. Okay, because we said a pure substance, right? We can say a pure element or a pure substance. And even if we did, it still could be a mixture, right? Okay. A distinct set of physical and chemical properties. What's that? Yeah, so like you're saying that compound A, that's mixed with compound B, compound A goes at 3, compound B goes at 100. That would be this, right? Compound A with compound B only reacts with it. So they could have distinct. Yeah, that's right. Yeah, so the boiling point of solution, now, does this describe a mixture? The boiling point of a solution will increase with time. The boiling point will increase with time. They're saying if I have a mixture of a solution, I add something to it, is that going to have an effect on its boiling? Right. So it can cause an effect on its boiling, right? So in this case, would you guys say it's probably all of the above? That's what I'm probably saying. All of the above are, because all the other ones are true. And then the one that doesn't. Okay. Which of these is a solid? Which of these is a solid at standard ambient temperature? A solid at room temperature. So which one is solid at room temperature? Iron, water, mercury, or oxygen? Iron.
No. Oil.
Oxygen. Or what is that?
No.
Yeah.
Iron. It's solid at room temperature or ambient standard temperature. Which of the following properties is distillation based upon? A, pore size of the filtering device. B, relative density. C, inhomogeneity of the viscosity. D, boiling points. E, melting points. Say boiling points. Boiling points is correct. Yeah, sure, right, Jamie. Next time. Problem is that I will eat all, do not get the answers, and I can't eat because I'm upset. Let's see, which of the following is the best mathematical expression to represent the fact that pressure
of a gas, P, and constant temperature, and T is directly proportional of that of the mass. So you said the first one, that is correct, the first one is.
That's simple.
That's
Yes. Well, it also no, it means proportional, but directly proportional to the fact that they're both on top, right? That means that they're directly proportional, right? That means that pressure would go up, mass would go up. If it would be, yes. Yes, it looks like a fish. So if they said pressure and volume and pressure are in directly proportion, right? So it's 1 over. So as pressure goes up, volume will go down. So this is indirectly or inversely proportional. And this is directly. Right? It's spelled direct. Yeah. Okay. Yeah, so it's 1 over, they're going to be indirect proportion. Let's say you have the fish. If you have this and the fish and this, they're indirect proportion, right? Or inversely proportional, right? If you're this, the fish, and that, perfectly, that's why it goes up, then it goes up. So the temperature in the laboratory is posted as 295 Kelvin. What is the temperature in Celsius? I'm switching guards here. He's taking over for a minute. Oh, you guys ready? Oh.
I'm ready to go. No, we go to that one.
Yeah, that's an experiment.
What do you want to make it?
You're on the up.
You're on the up.
It's on right here.
Right. It says the 5 is next to it, yeah.
Well, it's you're putting on right here, and that is higher than 5.
Right. Oh, you said you were, it's long.
Because I got some.
Yeah.
It's really- Like, you guys know how to do this?
Which one?
This one.
Okay.
Oh, it is. Okay.
No, no, go ahead. No, finish. It's all you. Okay, so it says. Okay, so this is the energy of a photon of light is directly proportional to the frequency. If you guys, or what you guys should know, is that we did something like this. But now we're saying E is directly proportional to F, right? Or we call it nu. Remember we talked about nu? I have new shoes, right? So E is directly proportional to nu. E represents energy, nu represents our frequency. Okay. So it says calculate the value of the constant, the proportionality constant. So in other words, how can I make it so that E is going to equal mu, right? So we make a constant. We're going to use this constant. We're going to call it K. This represents any constant. Okay. So we put it on. Let me write the numbers down and then we'll put it on the board. Okay. This is E. This is E. Okay, so you can flip it. Okay. So if I want to solve for K, I tell him to flip it and he walks away.
Oh.
Oh,
I have
you
problems.
actually can.
What's that? That's J for joules. So joules is the form of energy. 1/2 is for frequency, right? And so we're saying we have this constant, right? And our job is to calculate this constant. They told us that they're directly proportional, right? So we know that that's what this means, directly proportional. Because if they were indirectly or inversely proportional, it would be 1/that one. Okay. So if I want to solve for K, how would I solve for K? So I'm going to K by itself first. I divide both sides by nu. So then these cancel out. I get E over nu, right? So K is going to be equal to E over nu. And then all we have to do is plug things in. 4.4 times 10 to the minus 19 joules over 6.7 times 10 to the 14, 1/2. So then my final answer should be something that is joules times seconds, because this is going to be inverse, right? And then somebody do the math for me. What is 4.4 divided by 6.7? That's all this thing. What? 0.66. Oh. 6. You said 0.66?
Yeah.
6.6 times 10 to the negative 34. You guys can plug the whole number in. What was that?
What is it?
Because you said it was 0.66 times, okay? If we look at our exponents, this is 10 to the 14, right? On the bottom. So that's the same thing. Since it's on the bottom, that's the same thing as saying 10 to the negative 14 on top. All the way down. Okay.
So you add them 14 and 19.
Yeah, so you have minus 19. Okay, so anytime that you're working with exponents, right? And I have 1/10 to the 7, right? Okay. So this is the same thing as saying 10 to the minus 7, because it's on the bottom. Okay, so in this case, these guys are going to be equal, right? So in this case, all I'm doing is I'm bringing this guy up and putting the negative sign. Okay, and then I can add, since they're both base 10, I can add the exponents together. So it's minus 19 minus 14, so that's 33, right? But
34.
oh, I know. But you told me that it's it's 0.66, right?
Yeah.
So then I need to move it over one more, so that's another minus. So that's why I got minus 34. Okay, where's our $20? Okay, so which answer would it be? It would be the last one. And you see how they play with you, right? They give you both the right answer, but the wrong units, right? This one is the wrong units. So even if you got to narrow down, you got to pay attention to your units. And remember that if it's 1 over S and it's underneath, then you got to flip it. Okay? I have a question for you because we've been having this argument in my learning area, my department, right? We're the STEM department, and I feel this is my opinion. How many of you guys took stats for your math class? How many of you guys took math 16 for your math class? How many of you guys did take math? Yeah.
I took.
You took math. Do you remember which one you took? No. Okay. So I'm going to say half of you guys took stats, and none of you guys, one of you guys took math 16? Math, pre-calc. Any of you guys took pre-calc? Okay. So my belief, this is certainly my belief, right? My belief is that you guys take stats. When you guys take stats, it puts you at a disadvantage for a course like this, because pre-calc and other courses teach you that aspect of exponents, right? And we use a lot of exponents, a whole lot of exponents. And then we also use, other forms of math as well. We're going to use a little bit of sine, a little bit of cosine, all of those things. And we've kind of debated whether we should have a class that's kind of dedicated to you guys. It'll be like a 4-week class or a 5-week class to help you succeed in this class, right? And it would be taken like we started probably 2 weeks or 3 weeks before this class starts, so that you would get that math part of it, and then you get come in and then you just be acing all of this crap, because you guys, it's like you've learned it before. I know you've learned it. You guys probably learned it in high school or whatever, but you haven't used it in so long. And then when you probably learn it, you're probably doing what every kid does. We all do it. Why the hell do I need to know this? Because I'm never going to use it, right? That's what everybody says, right? And then you get up here and you're like, fuck that stuff, right? And then, and so what I proposed to my boss was that we get a class like that, and then make it not so it's a whole fucking semester. I can the rest of you pass it or fail. I just want you to sit there and have that information, right? And so we're talking about making it a non-credit or a course, no points essentially, right? So you just take the class. If you want to take it, there you go. Great. But here's an opportunity to help you pass this class. Right? Would you guys take it? Especially since it's not so long. The key is I only want it to be like an hour, maybe at the most 2 hours a week. I don't want it to be like 8 hours a week. That's the same. I want it to be short, and just give you the meat of it. And so it's a lot easier for me to give you the meat of everything. I'm just talking not part of it. Then you can just.
Would it be like when you were taking break? Would it be like
yeah. Okay. Yeah. So it'll be associated with it. I recommend it, strongly recommend it to take. So, yeah. And so that's what I'm thinking, because I think, you guys are, my opinion, to be honest, strictly honest, you guys are brilliant at understanding the concepts, especially this class. You guys are really good at understanding those concepts, but you guys struggle with the math, and you guys get intimidated by the math. And I'm sitting there, I'm like, they're like brilliant. And at the same time, I'm like, this exponent, you should be able to get that, right? But I can't blame you because I know I did the same thing. I don't. You forget it, you just like, okay. And so, and then you let yourself get discouraged, and then you set yourself off behind. We want to keep that from happening. We want to make sure you guys get to the point. So, we've been arguing about it. I put it in mind. I did a program review, so for chemistry, we're trying to get our program together. It's been a long time. This is my whole week. It's been crazy. A lot of arguing about what I want. And a lot of people said, well, if you don't make it do it, then they're not going to do it. And I said, I think that they will do it, especially because I think most of you guys want to succeed.
You're like, you don't think they'll do it if you don't?
I would not be the one that would take it, like, okay, say if it says, oh, strongly recommended. If I don't need to take it, then I'm not gonna take it.
Okay.
That's
So-
just me coming in.
So what I should do is I should have
Or
two
when I'm not
classes,
just
right?
being.
I should have the class, I should have a class that I do solely online, all that stuff, where I don't do that class, then I say my face-to-face classes, okay? You gotta take this class. So it's a package, it's a package course.
Yeah.
They should at least make it at least 1 credit.
Yeah,
I'm trying to people will take it.
if it was for work, one credit,
Yeah, if it's no credits, I'll take.
go ahead and take it,
Yeah,
but if we make it work that one
at
credit.
least 1 credit or something, but.
I thought I'd ask, because, we're making decisions about your life, and I didn't talk to you guys about it, right? So I figured I should probably talk to you guys. But-
Especially the counselors knew
Yeah,
that background when we asked them how to register the classes, and like, this is why.
Yeah.
Just more than just on the screen, yeah, saying, well, let's go to the counselor and they're like, want to take this class, but why does it say that?
Yeah.
And then give me that background, and say, like you said, I would be like, oh, okay, yeah, I'll take it, yeah. But if I'm just, if there's, most people probably, wouldn't do it.
okay, that's good. And we have that, we do a very poor job helping our counselors help. And that's not going to be that cheap part of what we do. Because I have all these students that are graduating, I have 11 starting grad school. I have one, she's in a PhD program, she got accepted, she's already gone, and everything, right? And then I have 4 or 5 more that will be starting grad school. Well, 2 that will start next, and then 2 that are just waiting for their acceptance. So, and they all said exactly the same thing. They said, I wish our counselors would have told me not to take these classes, but to take these classes. Because all of you guys are going for liberal arts, math, and science, right? And they tell you to take the easiest way to take math 45, take this, take that, take this, right? And then they want to call you up with the easiest classes to get through. But that's not always the best, because in the long run, you end up suffering, because if you, like I said, if you took, pre-calc, then you guys could have worked this stuff and you'd be struggling right now. It's harder than science. Pre-calc, yeah. It's not really, it's not too much harder, but yeah, it's just a different type of math, And then stats. What was that?
Is it less confusing because it's still just?
Yeah, stats is like when you just plug and right, so there's not a lot of thought that's involved. Where I say pre-calc, there's a little more thought. And then people, I get it. You want the easiest road, right? It's relates, it's bottom line. That's what it boils down to. You don't want to do any more work than you have to. I get it. But you have to think about your future and whether or not you're going to be able to make it, with what you have, or do you need a little.
But what also helps to it word of mouth. We're in this class,
Yeah.
we know the other students that are gonna be there. But I already know some in my other class are like, oh, I'm taking chemistry next semester.
Yeah.
And I'm like, oh yeah, cool, like, and now that I know that,
Yeah.
I just say, what, I just make sure to take it. With the
Yeah.
students.
Yeah, that's true. That's true. Yeah, and so again, I'm glad I talked to you guys about it. I've been planning on doing that because, as I said, I want to do it, and then I get pushed back. I get it. I don't want to take another class. I don't have to, but if I think it's going to help me, I'm like, get out there.
Yeah.
Especially if it's only like 5 weeks instead of 18 weeks. Okay, so you guys understand this part though? And the key is, the secret is that, you guys don't know anything about energy. Well, you know this much about energy, right? Because we talked about this much, right?
It's just knowing the formula.
That's right.
That's it.
But
proportionality, right? Anytime you say something is proportional to something else, if you get a constant, you can say it's equal to something else. That is the secret. And so, Shay, you can figure anything out if you know that, right? I mean, anything. It could be, you could talk about pails of water going into the stream and stuff like that. As long as you know that they're directly proportional to each other, right? That means they both are going up at the same time, or one is going up and one is going down. You can put a constant there and make it equal, right? And that's gold. So then you can sit there, you know, and I'll be honest with you, I've gone into tests not knowing a damn thing about the topic, but I know my units, right? I follow units like anything. I keep track of the units, right? I can go in, I can figure out a fucking answer. As long as I know the units that I'm looking for distance. Oh yeah, I can figure out a shitload of numbers. I'll figure out a way to get just distance by making sure of the units. That's what it's about. It's about units and understanding whether directly and indirectly proportional. I can bullshit my way to an answer, you know, and 9 times out of 10, I can get it right because I recognize that the mental analysis is going to be where I want to be. And then I recognize that I know that if it's directly proportional, it goes up together, right? And that means that it's going to be on this side of the equation, and this guy is going to be on this side. It's going to go up together. If it's indirectly proportional, which means that it's 1 over x equals y, you know? So then, or proportional to y, then that means that I know that if y goes up, x is going to go down, right? So as long as I remember those things, I can work my way through any equation. I can figure it out if you're giving me something like this, right? So, and that's, it's very valuable to know because sometimes you get in that situation where, like, for a job, I had 3 job interviews that pulled that graphic. I'm like, man, it's been years since I've had this stuff. I've seen that, you know? And I'm like, okay. And then there's, well, you know, it's directly proportional. I'm like, oh shit, now I already know, got the answer. So I can sit there and say, and I worked it out, and I'm like, what the fuck? And then, you know, they were just amazed that I remembered that, you know? So if you remember that, try to remember that when you're thinking about these equations, right? And the other thing is like, when we're talking about lines, we often will talk about how it's linear, right? Well, we know that we're talking about linear. Well, so the equation of a line, got real quiet. Turn it off there. I guess you're ready. Take us out there soon. Turn it off AC in it. So, you guys remember this? Yeah. So, anytime that I see a line, this is the first thing that I think about, right? Rise over run, rise over run. That's the slope, the intercept, right? So when x is 0, then it's going to equal b. So that's where it's going to intersect the y-axis, right? So I'm like, okay, yeah, I got that down, you know? So things like that, those little things that you guys, we take for granted or we forget, those are the little things that can sit there and help you figure out something that you may not know, right? And so in terms of equations, so just kind of pay attention and pay attention to those words, indirectly proportional, right? Because they always throw that out, you know? And it's like, okay, I already know what that means, you know? It's like, I know what directly proportional means, we're going up together, right? Indirectly, yeah, I'm opposite of you, you know? We're going opposite ways, you know? Okay, so let's move forward. Ooh, more conversions. Thank you. Is this helpful for you guys?
Yes.
We're gonna have time, so we'll do a couple more, and then I'm gonna let you guys handle it on your own. Do you want to skim through to see, because you guys can do conversions. I'm not too much worried about that, right? Especially when they give you the conversion factors. You see something that is attractive. I know that there's one down there. Let's get to we've done a lot of those, right? Let's do isotopes. So what would I do for this one? It says I have 2 natural isotopes. So 2 natural isotopes exist for silver. 51.83% of the atoms have a mass of 0.90509 units, and the remaining fraction has a mass of 108.9047 units. Calculate the atomic mass of silver. Okay, so how would I go about doing this? No, it's not third. How would I calculate? How would I calculate do it? Don't worry about the answer. Only calculation.
Oh, right.
Okay. Hey, remember, these isotopes represent all the isotopes of silver. There's two of them. One of them is how much? What abundancy? Okay, we have one that's at 51.83%, right? So that's the abundance. That's how much of it's nature. That's kind of like if let's say you're a really good student, right? Overall, and you get A's 51.83% of the time, right? So that's greater than 50% of the time that you get A's. So can I use that to sit there and calculate your average? Okay, let's say you get 100% that amount of time. So you would use that to sit there and calculate. Okay, but let's say the other percentage of the time, that 48.17% of the time, right? You get C's. Can I calculate your average in that class? Right. By using both of those numbers, right? So that's the same thing that's happening here. We're calculating the average weight of silver by using the percentages. So we need to multiply. This one is for that first isotope, that 106.90509 units. And then we know that the other one is the difference. It's 100 minus 51.83, which is going to be 48.17%. Okay, and then that one's going to weigh 108.9047 units. So we change this number into decimals. So we go 0.4817. We're going to multiply that by 108.9047. Okay, now we know that this is multiplication. How many sig figs should I have? 4. I should have 4. Somebody do the math for me and give me 4 sig figs. Say it again. 107.87. Just for this one?
Oh,
You're talking about the whole thing, right? Yeah. So just do it for this one for right now, and then we'll get there.
I got 52.45.
Is that 52.45?
Yeah. Wait, 46.
46. Okay, so then we have the other one, which is 0.5183. So again, change this into decimal. We multiply that by 106.90509. So somebody do that for me. All right, you guys are just set. Hey, hit that button. The green button. And then hit. Thank you.
So, somebody do this one in their calculator. So 55.41. So if we add these two together. What was that?
Did you get 2982?
55.4.
Tell me the, wait, yeah. I think it's. I think,
Okay, so wasn't that one of our options?
Yeah, that was. I think it was that one first. One of the bottom.
Okay.
and then you're change, you want to change that to a percentage, you divide by 100.
You would change that put to percent because it's the average mass, right? So you're gonna put units, right? So units divided. So you need to pay attention, that's that part about paying attention to the units. If we wanted the percentage, you would say this over, you know, if you're calculating percentages. But typically, if you're given percentages, you're not gonna go back to percentages, right?
Oh, yeah.
Okay? And so just sometimes we get anxious and we don't read the question, you know, that little bit of anxiety. How many, because I know I've done that before, you know, like, yeah. And so I always have to catch myself. I have to slow myself down for a minute. Okay, breathe. Okay, now let's underline what they're asking for. What is it that they want? Oh, they want mass. I know what my mass is, right? Units of mass are what? Either we're gonna have units, AMU, right? That's gonna be forms of mass, right? Atomic mass, molar weights, right? Okay, now we also know if they're just saying mass, it's gonna be grams. It's gonna be pounds, you know, so. Okay? Okay. Let's do this kind of question.
Which one?
What was that? So let's talk about the different radiations real quick. So number 36, it says which of the following list the three principal
forms of radiation emissions in order of decreasing mass. So we're going from high to low, right? Okay, so we're going from high to low. Okay, so what is gamma radiation? Okay, so gamma radiation is going to be the same. It's not going to affect, right? Okay, so gamma is probably going to be the least because there's nothing on it, right? Okay, and then we have alpha. Alpha is going to be the heaviest because we know that alpha is going to be Ag42, right? Then beta. Yeah. So that's E01 minus 1. Yeah. And then gamma. So pretty much gamma and beta would be probably comparable to each other. So we know that it's probably not, we know it's not the first one. We know it's not the second one. Alpha, beta, gamma. Okay, a positron. A positron is what? Positive electron.
No, I think she said transform.
Let's see.
It's the plus.
Okay, so choose the correct nuclear symbol for the missing species to complete the following nuclear bombardment equation. So remember, when we look at this, is that these guys have to add up, right? So what is going to be the mass of this element on top? It's going to be 28. Totally 28, right? But we have one neutron, right?
Yeah.
So then we have to subtract that one neutron, so that should be 27. So that top should be 27 because we have N10. Okay. So then what is on the bottom? 13. Okay, so which element is 13? So the correct answer is B. Escape? Okay. So always remember that they're going to have to add up, right? Okay. So here's the next thing. Let's see if I can find a problem.
Is it 9 at the bottom?
Was that? No.
Yeah, it's 9. I'm deep.
Yeah, you got it. Forward. Okay. So let's say we have.
Oh, what about that conversion? To grams?
I'm just getting ready to do one of those.
Really?
Yeah.
Okay.
So, let's see, we have. Okay, so this is the last one, and then I'll let you guys go. Okay, so potassium 42, half-life is 12 minutes. If we have 1.0 milligrams of potassium 42 after 3 hours of sitting on the table, what is the mass of the starting material? You guys a second to think about it. Plan it out. Get your attack. It's filling. Yeah.
Yeah, there's also. Keep getting headaches, right? That's it. It's that trade-off, right? And then beats by the. Oh, yeah. Yeah. It's hard. What's that?
Okay, you guys good?
Ready to go for it? No? What's that? That's how you do it. Okay, so let's see if we can do this. So we have 3 hours. How many hours are in a minute? Or 60 minutes in an hour? It's a long night.
That's my brain every time.
Okay. So that's 180. Okay, so we have 180 divided by 12.
Oh.
And that's going to be our n.
So that's because you want to get to the half hour. We have 3 hours.
That's right.
That.
So 180 divided by 12. 15. Okay, so then if that's my n, I know my equation is going to be R equals S 1/2 to the n. Okay, we want to solve for S. So we have R over 1/2 to the n. Okay? And so that's going to equal S. So let's go ahead and plug that in. We know that this is 1.0 milligrams divided by 1/2 to the 15th power. What's that? Your answer 7.5.
I know.
I think it's gonna be bigger than that. Let me plug it in to be sure. So if we plug in 0.5 to the 15th power, and essentially we have 1, so we put, so we have 0.5 xy 15, and then we take the
Sorry.
32.
It's. I know. Yeah.
Yeah,
So, you want me to show you how to enter the calculator?
Yeah.
I remember. Yes, show me how to enter.
Yeah, I remember the other day.
Okay.
wait.
Oh, the CP process.
Oh.
So you go. So, do you guys remember that? If you guys remember, this is over. Right. It's 1 over, so then it's the same thing as saying 0.5 to the negative 15th power, right? Because it's inverse, right? Okay, so since it's 0.5 to the negative 15th power, what I can enter is I can enter my 0.5. There's a key that says XY. And then I hit the button that says either minus, or I hit the one that says plus minus. Now, not the negative, not subtraction, but there's a minus in parentheses, right? So some of your calculators will have this or this, okay? And then you're gonna put 15, and then hit enter. Yeah.
Like you don't have to calculate all that.
On the
You take the
screen.
test on the screen.
It's harder, right?
Yeah.
Yes.
No, that's it.
Yeah. Like, I know that the. I know. That's true.
You know, I don't get why.
Yeah, that's how we sort of how.